Hello all, welcome to Tech with SAS. In this video, we will talk about AI chatbot architecture. So in systems which are non-AI or like the systems which are used to till now, right? If you want to have a system where is this some chatbot or maybe some user want to have some data from the background, right? We use the kind of a rule engines where we have the predefined rules in a system, and when user submits their query or request, we have the orchestration happening, and that orchestrator will call the multiple data APIs and return back the data to the user. Okay, so all those flows which we are very used to or kind of expert, right? Those flows are basically deterministic flows. So there, whatever the REST interface or whatever the systems you have, they have predefined request response. So user knows, okay, if I suppose they want to know their the account balance, so they will invoke the get account balance API. Okay, and I mean, user can't do much, right? So it cannot ask the questions which are a bit of the probabilistic, because uh, these those systems basically focus only on the predefined rules or the deterministic flows. So today, there's a need of the understanding of architecture when system has the kind of a mix of both flows. Maybe there are some queries from the user which require the deterministic solution or answer. For example, if user want to know their credit card limit, right? That cannot be probabilistic, deterministic, because that is not like a some probability answer. You have to get from system and send it back. Okay. But if you want to know the pattern of their basically the future expenditures, or maybe uh, what is the most likely merchant they are going to shop next, you can't use your systems which are already existing and use the predefined AI API interfaces, right? So for that, we will have to use the AI-based architectures. So in this video, we will understand how these flows work. So here in this architecture, you can see that there are multiple new terms. Maybe there are new terms for some people, or maybe I mean some are aware. But let me just go through a bit of these new terms. This thing you are aware, right, is a bank site or some kind of a chat UI where user can type in their queries. Now, these queries need not to be predefined queries, right? Because we are having the AI system, so user can type in their queries in a very natural language way. Okay, whatever the way they want to write, they can type in over here. So whatever the prompting they are doing, it's up to them. There is no defined template as such. That's the beauty of these systems. Okay, then we have the AI agents. AI agent is something which are specialized in some kind of a uh, uh, topic, or maybe whatever the way you want to do them work, right? So you will configure your AI agent for a specific work. For example, if you talk about the bank context, right? In the bank, there might be systems for the credit card, for the mortgages, maybe also for wealth, right? So you can define the multiple AI agents, and those maybe one agent will focus on the systems which are focused on the wealth area. Another AI agent will focus on the systems which are credit card, and so on and so forth, right? And also there will be the agent orchestrator as well, because uh, whenever input comes from the client as a prompt, it should know that which agent would be working, right? So we'll see the flow in a while, but before that, we have also agent tools, right? So agent tools are something that might be required by the agent. For example, a wealth agent might need access to some kind of a tools which it can utilize for calculation or finding returns of the particular stock over the like a few years. I mean, so whatever the tools which enable the agent to find out the answer or query to, solution to the user's question, they are configured as agent tools, right? They can be some softwares, they can be some kind of a utilities. It depends, right? Then we have the LLM. LLM, I think everybody knows. They are the large language models. So basically, like we know about the Chat GPT, Gemini, Claude, right? So all these are the LLMs which have been pre-trained on the huge data, right? So that they know almost everything, right? So LLM is basically something which is the brain of your whole system. Okay. Another component here we can see the MCP, that is the Model Context Protocol. So see, so here, right, we have these new components. So in a bank system, right, uh, we already having the so many APIs which are utilized for the deterministic flows. Then there would be many SORs, uh, source of reference databases, maybe many huge systems for the like ETL processes. So we already have data in our databases. We already have APIs to connect, right? But how do we connect these APIs with our new component, right? This agents, LLM. So for that, we require the model context protocol. So basically, if you haven't seen the code of MCP, it is almost like a API only, but what it does, it basically tries to understand that based on the intent of the query from the user, which API it has to call. Okay. For example, if customer want to know the balance of their account, right? So MCP will know, okay, so this customer need a response about the account balance. So it will be able to invoke the account balance API if configured already in system. So in that way, there is no hard coding required, right? So there is no need of a universal orchestrator and doing some hard coding over there. Okay, if account balance call, please call the account balance API. No. So MCP is kind of a, um, I would say in my language, that is soft orchestrator, which is able to call the pre-existing APIs to get data required. Then we have the RAG, right? This retrieve, augment, and generate. So as we know that in this whole architecture, LLM is basically the brain of the whole system. But this brain is not uh, the brain for the bank itself in context of bank, right? So this LLM knows everything about what is in the public domain. All the data in the public domain, it is has been trained. But because if you talk about the bank sector or healthcare, whatever system, right, domain systems, every company will have their own data, and that is not publicly available. So now there's one option that either you take this LLM and start training your data, which is part of your system, to this LLM. Okay, so there is one solution. So that will be a bit costly because training a LLM will be a huge cost, and also data will be also evolving. For example, the bank policies might change, there might be new APIs in the systems, there might be new applications, okay, coded or maintained or modified, right? So every time there is a change, you need to keep up and keep training your LLM. So that is not feasible, right? So what we do, so for every context, so MCP will connect with this RAG, okay, and that RAG kind of a crawler across the enterprise document repository or systems, and that fetches the chunks of data and basically give as an input to the LM in the context. So these are basically the uh, core components of the modern AI architecture, which when we try to build the chat-based systems. Okay, so now having understood about the new components, let's talk about how the flow works. One more thing, we also have this kind of a secure data component. Basically, you want to kind of a mask data, which is kind of a PI data, like personal data. Suppose like this account number or something like that. So those things we have to mask, right? So flow wise, basically, suppose we have a user and which types in some kind of a query on this bank chat prompt, and it sends to the this system, right? And in this system, we will have this agent logic, or basically agent orchestrator. That orchestrator will basically tokenize these sentences and find out the intent of the query. Based on the intent of the query, it will invoke the corresponding agent. For example, this request is coming for the mortgage. So this will agent orchestrator will basically invoke the mortgage agent. Now, this AI agent will invoke LLM via MCP. So now MCP will definitely try to connect with the existing APIs and also the RAG system, so that it get more data or more context for LM to interpret. So basically, MCP will try to invoke the existing APIs for mortgage systems and get data. And along with the RAG also will be invoked to get data which is required for the mortgage questions. And then maybe the system prompt, whatever the predefined system prompts and user prompt, and plus additional context which we get from the existing APIs, plus the RAG data is fed to the LLM. And then whatever the LLM, because LLM will be having data already predefined, I mean, already pre-configured or like a pre-trained, right? Then with this additional input from the MCP and RAG and existing APIs of system, it will generate the output. Now, whatever the output it generates, we have to basically filter that so that no data which is like a personally identifiable, for example, account number and all, those should be cleaned before we send back to the user in the response, right? So this is a whole flow of a typical AI chat architecture system. So the various component involved here are the AI agent, which uses the agent tools depending upon their configuration and requirement. And then we have this LLM, which are the pre-trained, and then we provide the extra context via MCPs, which fetch data from the existing APIs from system, plus the RAG, which is basically kind of a crawls through the system, these applications repositories, and then the LLM generate the output. After we provide we put the some kind of a secure guardrail, we send back response to the kind of a user. Okay, so this is basically kind of a typical flow of a AI architecture. Hope this is going to help you in your interviews or maybe in your project as well. Thank you for that. And if you like this video and it helps you in a maybe some way, please subscribe my channel and like it and comment as well. Thank you very much.